Bismillahirrahmanirrahim. This is teacher Iman explaining from chapter 7, integration, section 7-2, indefinite integrals. The definition. If we have a function called h of x is defined on the closed interval from a to b, and if there exists another function f continuous on a closed interval a and b, and differentiable on an open interval a and b. Remember, the function should be continuous on a closed interval and differentiable on an open interval, and its domain from a to b closed, such that if you're going to derive this function h of x, you should get f of x for all x belongs to the interval from a and b. That means we are going to call the function h of x. H is the original function or indefinite integral of the function f of x on the closed interval a and b. And that can be defined by the function h of x will be equals to the integration or the indefinite integral of f of x dx. That means if you have, for example, sine of x to understand this definition. If you have h of x called sine of x, sine of x, and if you derive the sine of x, you will get cosine of x. And if you will integrate cosine of x, you will go back to sine of x. That's mean here h of x is always the original function that we're going to think about it before we derive. So you can see also in this definition that the integration is an opposite operation of the derivative. And the derivative is an opposite operation for the integration. So they are opposite operations. Let's have one more example, which is if h of x equals to x cubed plus 2 over 5, and a function called f of x is 3x squared. Then, if you're going to derive h of x, you will get 3x squared by taking the power down and reduce it by 1 and derive the constant to make it 0. And you can notice that it is the same as f of x. So that means if you integrate a 3x squared, which is f of x, if you integrate it, you should go back to the original function. Let us see how that can happen. H of x equals to the integration of 3x squared dx. Look, we took this f of x, which is a 3x squared, and we put it here to integrate it and do the opposite operations. That means instead of multiplying the power down, we're gonna divide. Instead of subtracting the power to make it 2 by 1, we're gonna add it by 1. Do the operations oppositely. So come on, we are going to add this power 2 by 1 to become 3 or to make it 3. And the result that you get, which is a 3, you are going to divide it by the whole term, which is going to be over a 3. So you can cancel that 3 with that 3 down to get x cubed alone plus c. Why we should write C? C, it means the constant, which is can be any constant you can imagine. But because we don't know what was the constant, we're gonna write a plus C. It is not clear here because it becomes 0 after we derive it. So to return it back how it was, we don't know what it was. So because of that, we are going to write it is a plus C. And if you want to check your work after you integrate it, you have to do the opposite operation of integration, which is derivative. Let's derive it. X cubed will be 3x squared by taking the power down and reduce it by 1. And if you derive a plus c, whatever the c is, you will get 0. So in that case, we are going to call x cubed plus c is the original function. Is the original function. Like we said here, h is the original function. It is the original function. Let's now go to the theorems of the indefinite integrals. For any integral, we have some theorems. Actually, we're going to mention them now all in this page and then have examples in the next. But we are going to mention some of them. Come on, if f1 and f2 are two differentiable functions, that means we can derive the first and derive the second, and the limits are exist for each. On the interval, and it should be open when we are talking about differentiable, from an open interval a and b. And if they have the same derivative, that means if you derive the first and you derive the second, they're supposed to be the same, then there is no difference between them except in the constant of integration. And we can understand this more by reading this statement and later by having an example. So if you're going to derive the first one and you derive the second one and they have the same derivative, you can see that their difference should be only in the constant. The difference between the two functions, not the two difference, the two derivatives, the two functions, the difference between the two functions should be the constant only. Now, to understand it more, wait for the example. Let's go to number two. If we want to derive the integration, we said that they are opposite operations like a square root and the square root with the square, or the opposite. They're gonna cancel each other, and similar with the derivative and the square, the integration, they're gonna cancel each other to give you the function as it is. The next is integrating the derivative. For the function, they're going to cancel each other, the derivative and the integration, to give you the function itself. But here you have to write a plus c. Why? Because, and here we didn't. Because here we are integrating. And when you are integrating indefinite, and also here means there is no a and b. It is not limited or bounded by any numbers here. So because of that, we call it indefinite integral. So integrating and then deriving, you should write C. But here you are doing the opposite. You are deriving, not integrating. You are deriving the integration. So no need to write plus C. In number four, if you want to integrate any constant value with a function, you should take this constant outside as a common factor, like that, like you did with the summation properties. And similar, if we have an integration for ag over x dx, you should take the constant outside like you did before. If we have in number five an integration for the sum or the difference between two functions, you should integrate each separately like that. That's mean integration allowed to be distributed for the first function and the second function to integrate each alone. Then add them or subtract them. We can have now some examples on each theorem on indefinite integrals. The first one, if we have f1 over x equals to x squared plus 5, then we derive it by getting 2x. How? By taking the power down and reduce it by 1. And the derivative of the constant is 0, so no need to write it. And if you have another function called f2 over x equals to x squared minus 6, you are going to derive it also by taking the power down, reduce it by 1 to get 2x. Look, try to compare between f1 dash and f2 dash. You will get here 2x and there 2x, and they are the same. According to theorem number 1, we said that if they are the same, there is a difference between the two functions, not the two derivatives. The two functions, not the two derivatives. So, but the difference between the two functions should be the constant only. Watch it here. This function has a constant negative 6. This function has a constant called 5. So the difference only in the constant. Let's go to number 2. D over dx. That means the derivative of the integration will be cancelled and giving you the function itself. And the dx will be cancelled with them because it relates to the integration. So here we are deriving the integration, cancel each other to give you the function itself. Similar in that one, derive the integration, cancel them to give the function itself. And here, derive the integration, you can get the function itself. In number three, integration for f dash. That means you are integrating the derivative. They're going to cancel each other to give you the function itself. But here, you have to write the constant because you are integrating. And what type of integration you have? You have indefinite integrals. And similar, if we're going to change the name of the function to g of x, you're going to cancel the integration with the derivative to make it g of x. And here, integration for h dash of x will be canceled to each other to give you the function itself. Don't forget to write a plus c. Integration for a f of x dx equals 2. Here, a is going outside as a common factor. Keep the function as it is till you're going to learn later the rules of integrations. And similar, if we have g of x, you're going to take the constant outside as a common factor. And if you have an integration for sum and difference between two functions, you can let it get in similar when you have sine and cosine. That means you are going to integrate sine alone and then integrate cosine alone separately, then add them or subtract them. We have actually a very, 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 very important principle coming soon with two parts. The first part is the integration of xn dx. And that means you are going to add the power by 1 and divide it by the result that you will get, plus c. Why you are adding it by 1? Because you are doing the opposite operation for derivative. In derivative, you were subtracting. So here you should add. In derivative, you were multiplying by the power. Here you are dividing by the power. In derivative, you were multiplying first. Here you are dividing the last. Plus c. Why plus c? You are integrating indefinite integrals. And we said that you should write plus c in indefinite integral because if you want to derive it, you're supposed to make it 0 to give you back the function which is inside. And that can happen actually with that important condition, which is n should be not equal to negative 1. Should be not equal to negative 1. N should be any real except negative 1. Why? Because if it is equals to negative 1, that means we can replace this n by negative 1. Look, they have the same rule. But if it is equals to negative 1, we are going to replace this n by negative 1. And that means you're going to flip it down to integrate dx over x. And that will give you the original function that its derivative is 1 over x. Think with me. What was that original function? Its derivative is 1 over x. It is, of course, ln of x. So ln of x is the original function. If you derive it, you can go back to 1 over x. If you derive it, you will go back to 1 over x. So this is how we are thinking about the original function. Now, why we are writing it inside absolute value or a modulus? Because len do not accept negatives like square root. Do not accept it, even do not accept 0 because its domain according to its graph, if you remember, go back and see the graph, it is from 0 opened till infinity. And it's a graph like that, which is going from 0 open till plus infinity. So here len absolute value for x should be defined for positive values. So you have to write these absolute value. You have to plus c, where n equals to negative 1. That happened in this special case. Don't write here log, just write len. Now, examples for these principles. Now, in the integration of x to the power of 7, I think we are able to use the first one because n is not equal to negative 1, so we're going to add the power by 1 and then divide it by the result. Let us see how. Like that exactly. 7, if you add it by 1, you will get 8. After you get the result, you're going to divide it by the result, which is divided by 8 plus c. And this is the answer. Don't forget to write C when you are doing indefinite integrals. Now, what about the square root? We said that we can change it to a rational fraction or a rational power, which is half, which is half. And then, like principle number one, you have to add it by 1 and divide by the result. So come on, if you add it by 1, you will get a 3 over 2. And then divide it by 3 over 2. This is a 3. If you divide it by 2, the denominator of the denominator should be switched up to be 2 in the numerator. And that all will be as 2 over 3 plus c always because you are integrating indefinite integrals. Now let's go to the last, which is 1 over x. Here, if you're going to take an x from down to up, that will make it x to the power of negative 1. And negative 1, if you add it to 1, you will get 0. And you can divide by 0. That will give you undefinite value. So because of that, it is able to use a principle 2, which is that special case. So if you have an n is equals to negative 1, like here, when you are flipping it up and write it up, you have to make it negative 1. So you can't use principle 1. You have to use 2. That means the answer should be ln absolute value of Lx plus c. Because if you derive it, you will go back to 1 over x. Even here. If you're gonna derive it, you will go back to that one. Even here, if you're gonna derive it, you will go back to that one. But here, actually, we can't add the power by 1. We have a special case when n equals to negative 1 only this special case. That will give me ln x plus c for indefinite integrals. Now, more theorems, and we are going to discuss now a very, very important theorem called the fundamental theorem of integrals. It is fundamental. So take care about it because we are going to use it always. Now, the conditions of this theorem is if f is continuous on a closed interval from a to b, and if f is integral on f on the closed interval a and b, then the integration from a to b to f of x dx is equals to. In this case, you are going to think about an original, we say, an original function. Its derivative will take you back to that one. You have to think about an original function. If you derive it, you will go back to that one and make it between a and b. Then you have to replace instead of x by b first, it is always b first, minus replace by a second. And then this is our fundamental theorem. Let us see how some examples to know how to deal with. The integration from 1 to 3, 3x squared minus 4x dx. If you want to evaluate it or calculate it, you're going to think about, are we going to use that definition of definite integrals? That means I'm going to use limit when n approaches to infinity for summation delta x times f of x, or I'm going to use the fundamental theorem. My answer for you, you have to use always fundamental theorem for sure. Always use fundamental theorem for sure. But if he mentioned in the question, you have to solve it by using the definition. You're going to use the limit when n approaches to infinity for the summation, blah, blah, blah. So now let's use fundamental theorem for all. We are going to add the power and divide it by. After we're going to write all the questions, we can start solving. Solution for the first, watch it. You can see that it was x squared. By adding the power by 1, you will get x cubed. By dividing x cubed by 3 down, you can cancel that 3 with the 3 that you're going to write it down to get x cubed alone. So you are adding by 1, dividing by the result. Then cancel if there is something to be canceled minus 4x. The power above x is 1. It is not written, but it is there. And you're going to add it by 1. It be 2. It's going to be 2. And divide 4 by 2 because 2 is the result of division. So now we're going to have 4 divided by 2 is 2. That means you will get 2 as a result of the division. Now you have to replace from 1 till 3 in each x to evaluate or calculate this integration. Watch it. Here is 3. Let's cube it. You will get 27. 3. If you square it, you will get 9. Multiplied by 2, it is 18. Then we finish calculating for 3. Let's go to 1. In 1, do the same. 1 cube is 1. and 1 square is 1, multiplied by 2 is 2. Now try to subtract these together inside and subtract these together inside, and there is minus from the rule. Watch it. There is minus from the rule or from the theorem. So come on, these together will give me 9 minus 1 will be plus 1. So 9 plus 1 is 10. This is the value for this integration. And you can get the same value if you're going to use the definition of the indefinite integration by using limit and the summation. Let's now solve the second. The second is integration from 0 to 9 for square root for g of g. Look, we can change the inequality, the variable from x to y to z to g, whatever the letter is, it should be in terms of the same letter to be able to be integrated. Now we are going to change the square root to half, which is a partial fraction or a partial power. Now add it by 1 according to principle number 1. Principle number 1, add it to 1, you will get 3 over 2. Then divide that by the same, which is a 3 here divided by 2. And that 2 from down will be flipped up to be in the numerator. And that makes sense. Now you can change writing this g to the power of 3 over 2 as a square root to the power of 3 because this 2 in in the denominator is a root, and that 3 in the numerator it is a power. So we can write it here as a power, this numerator, and this denominator, which is a square root of g. And keep 2 over 3 outside that all. And this all from 0 to 9. Come on, how to calculate that? Keep 2 over 3 outside and replace instead of 9 here. If you find its square root, you will get a 3. If you multiply the 3 times, you will get 27. Then minus according to the rule of the theorem in the definition, on in the fundamental theorem. Now there is minus here between and replace by 0 later. 0, if you square root of it, you will get 0 like that. And then subtract. 27 minus 0 is a 27. Cancel it with a 3, you will get 9. 9 times 2 is 18, and that makes sense. Let's go to the third example, which is absolute value. Look, I give you different ideas with different solutions, but they are dealing with the fundamental theorem by using a principle number 1. So here, if we have absolute value, actually, wherever the absolute value, you have to redefine it. What do I mean by that? You have to write it when it is positive and once it is negative. So here, when it is positive, when the whole thing is positive, that's mean x should be bigger than or equal to 2. And when it is negative, when the whole thing is negative, that's mean when x is smaller than or equals to 2. You can study this easily here or by the number line or sketch it. Or you can sketch x minus 2, which with the Venn diagram. No, V diagram, with the V diagram, with the V diagram. So come on, we can integrate it and distribute it to two terms or two regions. Like we said before in the theorems for indefinite, they are similar to the indefinite integrals or or definite integrals. So if you can distribute it or divide your region, if it is that large from negative 2 to 4 to 2 regions, you should. Like here, I can distribute it from negative 2 to 2. But here, actually, in this example, I have to distribute it because I have a 2 here in the middle with two different functions. So once when it is bigger than 2, it has something different when it is smaller than 2. So you supposed to distribute it. So come on. So we're going to make our interval from negative 2 till 2 and take the negative part, which is that one. Actually, x is smaller than 2. That means negative 2 starts from here. Negative 2 till 2. Negative 2 till 2 is here. Negative 2 till 2 is here. So we are going to take that function. By letting this negative get n, that will make it negative x plus 2. And integrate it. Plus, always a plus between them. And integration from, you stopped at 2, so start by 2. Till you end your interval till 4. Till you end your interval till 4, and it should be in that function. X bigger than 2, this means from 2 till 4. We're going to stop at 4 because our integration is stopping at 4 in terms of an x, and then integrate each as usual. So the point is you have to use that theorem how to divide the integration to two parts. Now we're going to add the power by 1. Add it. It was 1. If you add it by 1, it's going to be 2 divided by 2. And keep the negative outside. Plus, if you have 2, how to integrate it? The x beside it, it is to the power of 0. The x beside it, it is to the power of 0. Add it by 1, it appears x. And if you want to be sure that your work is right, you are going to derive it. So if you derive 2x, how much you will get? 2 without x. So it makes sense that the integration for 2 is 2x. And if you want to derive this, you can take the power down and reduce it by 1 to cancel this 2 with this 2 to get back 1. So you can be sure about your work by deriving it. Now let's go to that part and integrate it. This x, it has a power 1 added by 1 that will make it x squared divided by the result of your addition. Minus it 2, if you want to integrate it, you have to add to it x. So it becomes 2x, 2x, 2x. So it is 2x. If you derive it back, it's going to go back to 2. And this is supposed to be replaced from 2 to 4. Let's do it. Now we want to evaluate. Now, can I put instead of an x 2, start by the biggest? If you put 2, it's 4. Divided by 2, it becomes 2. So it is negative 2 now. And in that one, if you want to replace it by 2, it is 4. Now let's go to that one and substitute by negative 2 in each. Yellow, negative 2 to the power of 2 is 4. Don't forget that you are having negative inside the bracket, and the negative inside the bracket should be positive. So it's 4, not negative 4. Divided by 2, it's going to go back to negative 2. Take negative 2 and multiply by 2. It is negative 4. This is for the first bracket. Plus from all. This is our plus. Now let's replace by 4 in each. 4 squared is 16. Divided by 2 is 8. And here 2 times 4 is 8 again. Now minus. Let's replace by 2. 2 squared is 4. Divided by 2 is 2. 2 times 2 is 4. We are done with replacing and integrating. Now we need to subtract and add. It depends on you. So here, these together will give you 2. These together will give you 6 minus 6. Well, multiply by negative is positive. And here this is 0. And these together will give me negative 2. By negative is positive. Now I think we can add. 2 plus 6 is 8 plus 2 is 10. So it's done. Let's now go to another theorem, which is also very, very important theorem. Because of that, we discuss it alone. And it is the last theorem for this chapter, which is the mean value theorem of integration. We call it mean value theorem. You can go back with your memory to say that we took this before in differentiation, the mean value theorem, but it was for derivative. And this is for integration, and it is going to be different a little bit. Now, it says that if f of x is continuous on a and b, then there exists at least one number c. Look, we have only one condition, not like the in the derivative one. Here we have only one condition, which is continuous. We are not talking about differentiable at all. Then there exists at least one number c belongs to a and b. You know why? Because we are talking about it in the integration. That means we are talking about area. Area. And when we are talking about area, we need only the function to be continuous, to be integrals from A to B. And this is going to appear somewhere to give me the length and the width of the region to calculate the area, such that this C should be between A and B, and it might equal them. Look to the difference between in integration and in the differentiation. In differentiation, we say that C should belongs to an open interval. That means it couldn't be at the ends. It couldn't be at the ends with derivative. But in integration, it can be at the ends because it is talking about area. Area, no problem. No problem with areas. So from A to B, including A and B, no problem to write equals here. And it gonna satisfies the following relation. This is the rule that we are going to deal with it when he gonna say that the mean value theorem of integration. An integration from A to B, f of x dx, will be equals to f of c multiplied by b minus a. This is going to be the length, and this is going to be the width. This is going to be the length, and this is going to be the width. And multiplying length by width will give you an area. Let's now go how to an example to see how we're going to deal with that mean value theorem of integration. The question can ask you to find the value of C that satisfies the mean value theorem of integration if we have the following function. F of x equals the square root of x when x belongs to a closed interval from 0 to 9. First of all, if you have a square root or a fraction, you have to be sure that it belongs to the domain and it is defined to the domain which is given. I can see that it belongs and it is defined to that domain because the square root always accept positive values. Be sure about this, please. Solution. First of all, the function is continuous, of course, because it is defined from 0 to 9 for that square root. Now, to find the value for c, you are going to write the rule. The rule says that from a to b, for the function dx equals to f of c b minus a. What is that a now? What is that b? What is my function? A is 0, b is 9, and the function is the square root. So we can write it from 0 till 9, square root of x dx. Now we have to complete writing the rule. F of c multiplied by a bracket instead of b 9 instead of a 0. We finish writing the rule. Let's now solve it. How to integrate this and how to evaluate this. Easy. To integrate this, like usual, you have to change this square root to half and take the power, add it by 1, divide it by, and that means you are going to get like we did before many times. We did it 2 times, and this is the third. You will get it as a square root for x to the power of 3 multiplied by 2 over 3. You can go back to 2 times we discussed it and we explained it before. Equals 2. This now here 9 should be from here. From here. 9 minus 0. 9 minus 0 is going to be 9. And that f of c, you are going to take this c and replace it instead of x here. Replace it instead of an x. Make it f of c. F of c equals to a square root of a c. So you have to write instead of f of c square root of c. And instead of 9 minus 0, 9. So this all from the right side going to be written as 9 square root of c. So you can see that we are solving the left side alone and the right side alone. And then we can evaluate each alone. Now, these together after you replace by 9. We did it before also. And we got actually 18. We did it in the previous page. and we got 18. And that all equals to 9 square root of c. Now you can divide both sides by 9. Divide that by 9. You will get 2. Square both sides. You will get 4. Ask yourself, is 4 belongs to your given interval to accept it or you don't? If it belongs, you accept it. If you don't, if it doesn't, so you will reject it. Actually, it does. C equals 4 belongs to the interval from 0 to 9, so we got a value for C. We are done with our lesson. We want now to have, like usual, some objective equations to be able to solve ministry questions. Choose the correct answer. If we have an integration from 1 to k to x minus 3 dx equals to 6. That means he give you the value for the integration, but the unknown value is that upper limit, which is k, for this integration. Then the positive, and focus on the positive because you might get negative. He is asking about positive. The value of k equals 2. You are going to have these choices and choose one, only one. 3 or 4 or negative 1 or 5. Actually, negative is not right to choose, but he wrote it for you to see if you are focusing or not. Answer, I think, according to the integration from 1 to k, 2x minus 3 dx will be equals to. Here, you're going to add this power. He gave it to you 6. The 6 is given from the question. You should integrate it from the left side and then equal it to the right side. Let us see how. This x has 1 above it. Add it by 1, it's 2. Divided by 2, you will get x squared alone. And then we said before, if you have a constant like that and you want to integrate it, you should write it as 3x. You should write it as 3x. We miss an x here, and you then substitute instead of a k in each. So you're supposed to substitute k here and k there once and substitute by 1 in each. That means, look, there is x here. So if you substitute it, you will get k squared minus 3k. 3k minus, you're going to replace each by 1. 1 squared is 1. 3 times 1 is a 3. Now that all according to the question equals to 6. According to the question equals to 6. Now evaluate each. K squared minus a 3k stays, and these together will give you negative 2 with negative is positive 2. That all equals to 6. I can see that we have a quadratic equation. We need to equal it by 0 by moving 6 to the other side and make it negative. That will be 2 minus 6, which is negative 4. Try to factorize it because it is a quadratic equation by opening two brackets like that, k plus 1 and k minus 4. Take the two numbers, their product is 4, and if you subtract them, you will get a 3. They are 4 and 1. And give the biggest the middle sign. The biggest will take the middle sign, which is negative, and negative times negative will be positive. This is how to factorize it, equals to 0. Then make either or. Either k equals negative 1 or, and this is rejected of course, and he wrote it for you to get, make you get confused. And then or k equals to 4, and this is the result. So we are going to choose B, which is 4, and it is a positive number. In number 2, the value of C that verifies the mean value theorem for the following integration. He mentioned integration. That means you are in this chapter, not in the derivatives. So integration from negative 2 to 3, 3x squared plus 2x dx is, you are going to choose from these choices. And according to the following rule, you have to write the rule that we discussed before in the previous page. It's equals to f of c times b minus a. F of c, you have to write the integration as it is without any changing, just equal it by f of c times b minus a. B minus a. I want to say something. Sometimes he don't say c. Sometimes he said any letter different than C. Sometimes he said Z, or sometimes he said T, H, M, O, whatever. So you're gonna write here F of the letter that he's gonna give you. So don't only focus on C. It might be any letter different than C. Now, how to solve that? We're gonna integrate the left side alone by adding the power by 1 by using principle number 1. Add it by 1, that will give you cube, divided by 3, you will get x cubed. Plus 2x, if you add it by 1, you will get x squared, divided by 2, you will get x squared alone. It is between negative 2 and 3 as here. And this is from the left side. Continue. It's all equals to. From the right side, what do I have? I can replace instead of x in each c, like that. 3c squared. 3c squared. This is my function. Plus 2 times c. 2 times c. This is my function. So I'm replacing instead of it. And then we are going to write it multiplied by b minus a. B is a 3 and A is negative 2, and there is a negative in front, so it becomes positive, which is finally after you add it, you will make it 5. Now you can open brackets and evaluate as possible. You are done with the theorem, you are done with the principle, and with the fundamental theorem. You used now three things. You used mean value theorem by writing this. You use the fundamental theorem by writing that. You use the principle by using here, and here fundamental theorem. Here fundamental theorem. Here fundamental theorem. And then you need to just evaluate it. It depends on you. So to evaluate it, you can multiply 5 by 3, it's 15c squared. 5 by 2, it is 10c equals to, or that all in the other side will give you here 20 7 plus 9 minus 8 plus 4, that all calculation will give you 40. Then you can say that 15c squared plus 10c minus 40 will be all equals to 0. Why you have to equal it by 0? Because it is a quadratic, and always a quadratic should be equals to 0. Now how to factorize it by opening two brackets like that. This is the first bracket, this is the second, by writing a 3c and here c plus 2. That all equals to 0. You know something what we did before we factorize it? We divide this all by 5. We divide it all by 5. So 15 divided by 5 is a 3. C squared plus 2c minus 8. It's all equal to 0. So it makes sense from this statement, and here should be plus. And in this statement, you should write a 3c multiplied by c will give you 3c squared. And the 8, it is 4 times 2, which is 8. And you have different signs because they have negative at the last. So that makes sense. 3 times 2 is plus 6, and this is negative 4. And 6 negative 4 is positive 2, and that makes sense. Either or c equals 2 4 over 3, or c equals negative 2. Let us see which one we're going to accept and which one we're going to reject according to the given interval. My interval is from negative 2 to 3. So negative 2 is accepted now. Not like in differentiation. In differentiation, we can't accept it at the ends. But here in integration, we will accept it. So it belongs to a closed interval from negative 2 to 3. And what about that fraction? 4 over 3, which is 1.333, which is 1.3333, which belongs to the interval from negative 2 till 3. So we accept each. So we have for C has two values, which are negative 2 and 4 over 3. No problem to have two values. The last one, the original function of for the function. Here f of x equals to 2x plus 3. If you know that its curve passing through the point. We are looking to find the original function from that function. So to get the original function, you need to integrate it. If you're gonna say original, that means you have to integrate it. To get original function, remember, you have to integrate it. So integrate it. What is the integration of 2x? It is going to be x squared plus this 3. If you integrate it, it's going to be 3x. And then you are going to make it a plus c because it is indefinite integrals. Like that exactly. Watch it. Here, f of x is going to be x squared plus a 3x. This is the things that you're going to choose from. But how we solve it? You are going to solve it by integrating the given function. By integrating the given function. This is the way how to find the original function if you ask. Then you are going to add the power by 1 divided by 2. You will get 2 with the 2 cancelled. You will get x squared plus a 3x plus c. Always a plus c because it is indefinite integrals. Now the point is we need to know how much is c. To know how much is c, you need to replace. Instead of by x by 2 and instead of f of 2 by 1, which is the value of y. So 1 is going to be replaced instead of y here. And the 2 is going to be replaced instead of x here. Here. Let us see to find see how. F of 2, instead of each x, I'm going to write 2. 2 to the power of 2 in the new function. Plus 3 times 2 here. I'm replacing here. I'm replacing here. Plus c. C is unknown till now. And that all should equals to 1. From where we got 1, it is f of 2. F of 2 is 1. F of 2 is 1. F of 2 is 1. So come on, let's evaluate it. This will be 4 plus 6 plus c equals 1, which is 10. 10 take it to the other side. That will make it 1 minus 10, which is negative 9. So the right answer and the right choice is going to be A, which is x squared plus 3x minus 9. Now let's go to number 4. If we have dy over dx equals 3x squared and the curve passing through 1 and 2, y is, so we need to get the value for y, which is the original function. Look, question 3 and question 4, they have the same idea. You have the derivative. You have the derivative and you need to go back to get the original function by integrating it. So you have these choices to try to choose. We are going to do the same, but before you are going to make a cross multiplication between dx and 3x squared and dy and 1. Like that exactly. You have to do that cross multiplication. That you will give you dy equals 3x squared with the dx together in one side. Now integrate each. So if you're going to integrate the left side, you will cancel the integration with the derivative like we said before. They are opposite operations, equals 2. And if we integrate the right side, there's supposed to be dx here written. So you're going to add the power by 1 divided by. So if you add it by 1, you will get x cubed divided by 3, cancel it with that 3 to get x cubed alone plus c. So the last answer is y equals x cubed plus c, which is one of these, x cubed plus. Now we need to know how much is c. How much is c? To know it, we are going to replace instead of an x by 1 and instead of y by 2, we can get c. So come on, this is our function, but in the curve, he said that the curve passes through 1 and 2. This means x is 1 and y is 2. Come on, 2 here equals to 1 cube plus c. After you're going to move 1 to the other side, you will get 2 minus 1, which is 1. So you got it, which is x cubed plus 1, which is C, which is C. Who did it right for these questions alone? Congratulations for him for understanding the lesson. And this is the end of our lesson today. I hope you all get it well. If you have any comments, any questions, please don't hesitate to write it for me. You are welcome anytime. And please subscribe and make like for me to continue with my channel. Goodbye. Thank you for you all.